So for the next 45 minutes, you're having a new team. So if you don't like your current team, I'm happy for you. But there are lots of sponsors out there that want new developers. So you get new choices, but I'm even happier for you if you like your current team. But the next 45 minutes, this is your team. So in the left upper corner, we have Emma. And Emma is 30 years old, and she is really into programming. She's also called the weekend warrior. We have Raj, and he is just from high school, not from high school, sorry, from university. He's very eager to learn, and he wants to know everything there is to know. We got John, and John likes Rust. So I have no clue why he's in our team. It's a Java team, but we have John, so we have to deal with him. And we have Ben. And Ben is our seasoned dev, and he is counting his days till he gets his pension. So in a digital world, not far from here, there's a Java ecosystem. And in this system, applications run smoothly, logs are fine, servers are stable. I really like it. But then some spikes came in. And some more. And I'm like, huh, what is happening here? So it was the start of the memory wars. And Anna and her team, they were puzzled. They were like, we didn't change anything. How does it come? And the traffic is just the same as before. Where does this come from? So they dig into the logs and they discovered something. The hidden enemy. Unnecessary inflated object headers. So question, who here knows what the JEP is? Can I see some hands? A couple, not everyone, so just to get on the same page. A JEP stands for JDK Enhancement Proposal. And JDK, another acronym, is Java Development Kit. So a JEP is a new Java feature, and today I'm going to talk about new features in Java 24. And who here works with quantum computing? Nobody. Aww. But just so you know, then we'll go fast over it. In Java, there are things for quantum computing. So if anyone ever says to you again, Java is an old-dated language, no, we have quantum computing. And JEP 496 is all about, I want to explain it, it's a model lattice-based key encapsulation mechanism, whole mouthful, but it's all about making it resistant to future quantum computing attacks. And the top one is all about the cryptography, so it's encapsulated. And the second one, the 497, that's more about moving the data securely. So first one is about cryptography, and the second one is more about the data and the authentication. And this also is already approved by the United States, the National Institute of Standards and Technology. You can all forget it now, but just so you know, Java has already this. Maybe better, more hands going here. Who here has ever debugged a memory issue? Yeah, most of the room, luckily. Let's talk about object headers. And when we create a new object in Java, there's always an object header created, and it has extra metadata. And how does that look like? Like this. So we have 46 bits for the mark word, and we got part from the class. So this is currently in Java 23. And if we look to the class word, there we have a compressed class pointer. And what does that mean? It says, okay, we're creating an object, and here we're pointing to the next object. And we take 32 bits for that. In the mark word, we have a couple of things. So we got the tag, and the tag is 2 bits. That's always there. It's just like a release tag. We tag the object header. We have the age because we wanted to know how new is the object. That's all for garbage collection. I don't gonna explain garbage collection today. There are lots of good talks, also from Gerrit Groenewald. He was also here today. But that's the age for the garbage collection. And we have the identity hash code, and that's all about what's in the object, the identity, the ID. And if you see that, you also see some unused parts. Huh, that's interesting. So we got here 25 bits, and another bit, and another bit. That's because Java, as you probably know, is already 30 years old. So we moved some things, we did some things. And one thing we did in the past was bias locking. And bias locking was already disabled in Java 17 and deleted in Java 21. And that were the small bits. And we did something with the concurrent mark and sweep garbage collection, so the CMS DC. And that was already disabled in Java 9 and removed in Java 14. So that's a lot of legacy. But now, finally, in Java 24, we're gonna remove them. And there's something with overriding. Because we have something called legacy stack locking, where you can override almost all of the object header and point it to another data structure, still with a tag in this, and lock in this way. And this is a very old way of doing it. And this was standard till Java 22. But luckily, in Java 21, they introduced lightweight locking, and in Java 23, that's now default. So we also don't need all the space anymore to override it. And with Anna and her team, they were very happy with it. Because with the inflated object headers, there was a lot going on in the system, and it was growing and growing. And because of the unnecessary object headers, they had a lot of ballast, and they didn't want to have that. So they searched and searched, and then thought, okay, I can do something with everything I have now, or should I use some new techniques? And of course, there was a deadline, so tomorrow, or yesterday even, they had to release something. So what should we do with it? And then Emma discovered Java 24, a new feature, JEP 450, sorry. The compact object headers. And because it's more compact, you can have more objects in the cache. And the best thing of all, you don't need any code changes to implement it. So how does this work? So in the top, you see the object header like it was before. So the 64-bit for the mark word and the 32 for the class word. And now with the compact object header, we only have 64 bits for everything. What did change? So the compressed class pointer is still here, but it's now smaller because before we had 32 bits, but they discovered the first 10 bits were always the same. And what we do with all things that's always the same, delete it. 22 bits is a new one. So that was already a 10-bit optimization. The identity hash code just stayed the same. We didn't change anything. As well for the age and the tag, we gave it another color, but it's still the same. And they introduced a new bit, the self-forwarded tag. That has to do with, again, with the garbage collection. When we copy the object and something goes wrong, it still points to itself, so it's like a backup. And of course, the unused bits are gone. But we introduced also some more. So here we see 4 bits of researched data. And what do they want to do with this? So here again, once the old and the new, not on scale. There is something called Project Valhalla, and Project Valhalla is all about optimizing Java. They have value classes that don't even have object headers, and they're all about improving the memory with primitive classes or even generic, specialized generics. So it's all about making it smaller and smaller. And we also have Project Lilliput. And what Project Lilliput wants to do is make the header even smaller. So now it's for 64 bits, and even reduce it to 16 bytes or even 12, and on the long run even to 4. So that's way smaller. And the cool thing about Lilliput is, and now some people that know some people, so I got the timeline from Project Lilliput. So now we are in Java 24. Java 25 comes later this year. Probably when JFall is, we already have it. And you don't have to read everything on screen. I will just tell it to you. So in Java 26, they want to compact full garbage collecting forwarding. The number in front of them is the Jira number. And they make use compressed class pointers obsolete and make the compact object headers deprecated. So what's now an experimental feature is then default. And in Java 27, they want to implement some compact identity hash code, so make that even smaller, the identity hash code, and start with the 4 bytes headers. Then we go to JDK 28. Then they want to make the tiny object headers, so only the 4 bits, non-experimental, and in 29, deprecate the flag, and then in 30, it should be there. So it's a long way from here. I don't know when 30 is released. They say now every half a year a new Java version is. Don't pin me on this, but this is currently what they want. So how do we use this? Just by doing this. So we're calling our Java application with -xx, and -xx stands for experimental feature. You use compact object headers with the name of your jar. That's all. No code changes, just add this. And if there's a 1x, it's a not standard JVM option for this one. So, the clock tickens, and Emma tries to use the compact object headers to activate this new web. And it slims, and it slims, and it slims. So she was really happy. And she saw that the size of the object headers shrank with 33%. The live data reduced with 10 to 20%, and the garbage collection only passes 3% less. So that's like quite an improvement with only one line and not even of code, just a command to do that. So is this the only way? No, of course not. We have alternative timelines. So let's explore one of those alternative timelines. Value classes. I already mentioned it with Project Valhalla. And what are value classes? So here we see a class point. We gave it some values, x, y, and z, and we gave it a constructor. And just assigning those. And when we say, okay, create a point with value 0, 0, 0, and there we have a method value of point where we check, is it the origin? And in the method, is it origin, we check if x, y, and z are equal to 0. And if so, then return the origin. If not, it's a new object. And we can also override the equals and the hashcode method. With the equals, we will check is it null, is it not another class? And with the points, we will check again the x, y, and z. And with the hashcode, the new one. When we're testing this, we can do something like this. So we have a new point with a value 1, 2, 3, and a 2.2 also with 1, 2, 3, and we do an assert equal. But if you do the same with the value point of 0, 0, 0, 4.1, and 2, and we do an assert true, it can be that this test is flaky because it's not the same. So in normal Java objects, this would be true, but because it's a value object and doesn't have the object header, it can change. So who am I? You maybe wonder. My name is Lutske De Leeuw. I work for Craftsman. I'm 10 years in IT. I'm a software engineer, studied computer science, and did some research in deep learning. If you scan this QR code, you can go to my LinkedIn profile and you can find me on the socials by my first name. I'm also co-organizer of 2 jugs, the Apeldoorn Jug and the Jug Noord. They're both here in the Netherlands, one in Leeuwarden and Groningen and one in Apeldoorn. We're also here with the stand, so if you see for us at sponsored booths, we're there, and otherwise, look for us. And also one last sponsor slide. DevOps for Kids. A little, DevOps for Kids is an organization from the DevOps family about teaching kids to program. And Little is the same, but then for schools, where we say, okay, we want to have programmers and school connected to each other so we can give guest lectures. So if you're interested in that, please also visit our booths. We're also here. So I'm always doing something that's called a speaker selfie. If you don't want to be in it, you can hide under your chair or come afterwards to me, so I'll put a back bar in front of your face. So let's pretend that we all just won $300 million. So just cheer, say yay! Thank you very much. So back to Emma and her team. So they lived happily ever after, right? No, of course not. We have a lot of time left. So let's talk about John this weekend. It was Friday afternoon. Everybody was committing the last things, pushing it through. And John was like, I really hate this. Application is so slow. And Emma was like, it's not that bad, right? And he was like, I just went to make coffee, slow coffee, you know, I don't like this one, so I take my time for it. And I came back and it was still starting. We have to change something. And Emma thought, yeah, maybe we should. It was Friday, so everybody put their laptop down and got home. And Emma went home, opened the laptop again. How can we change? How can we change the the startup time? So I'm going to tell you about how class loading works. So normally in Java, you only load the classes you want. So it's like a librarian. They only fetch the book for you if you want to have the book. So there's one class and another if you ask from it, and another. But wouldn't it be easier to get it all together at once, just not wait for it when it's there? So to do something like ahead of time class loading. And then we could just say all the classes at once. So if we have, for example, in the first part, a party and everyone at the door, you have to really check if they're the person who they say that. Not efficient. You want to invite everyone at once. And luckily, we have something for that. JEP for an 83. Ahead of time, class loading and linking. And with this, we can, in 3 easy steps, we can achieve it. So we have to record it, we have to create a ahead of time bundle, and then we can run it with it. But before we're doing that, another question. Who here knows the city Leiden? Almost everybody. And who here is Dutch? All the same people. Could be. But we have some non-Dutchies or some really shy Dutchies. So, Project Leiden, that started in the Dutch city Leiden, is very new. It's just from May 2022, so only 3 years old. And they're all about speed. They want to optimize Java. And to do that, they also made this, the ahead of time compilation that's now in Java 24. And Anna went to her computer and she did a Maven clean package and she started her hobby project, because why should you work on a company project if you have your own hobby project? And she started it, and it was started in 2.09 seconds. So pretty fast, but yeah, it was a small hobby project, so what do you expect? But she wanted to make it fast, so that on Monday she can say to Jan, I have a solution for the slow startup time. And to do that, we can do this. We have an ahead of time mode called record. We have a configuration where we say, put it there, and your jar, and the class you want to capture. So then you're gonna record it. And she started her application and clicked through something, because still, if you do ahead of time class loading, you don't want every class in your application, but like the hot path, so the classes you use most of the time. So if 80% of your traffic is going to some classes, that 80% is used. And after that, she did the ahead of time mode create, also with the same configuration, and with the cache, again with the jar. And finally, she could run it with the cache we just created, the jar, and the class. And if she ran it with this command, it was only started in 1.09 seconds, so 50% faster. Now, this is a hobby project for Emma, but I also did this with the Spring Pet Clinic project, so it's a very common one, and there it was 40% faster. So not in every project it's 50%, but 40% is like quite the normal. So if you do ahead of time class loading, it's way faster. And again, no code changes. So I really like that on this Java 24. There are a lot of features that are just very easy to implement and to have lower memory. So, is this the end of the saga? No, not again. We have still more. So let's talk about Emma's third challenge, scaling concurrency. So, one morning was during the daily stand-up, and John was saying something like, yeah, we can build it in Rust. I like Rust. Let's do all the critical parts in Rust. Like, everybody was like, it's the stand-up, it's Monday morning, please, John, no. But it got Emma thinking again, like, of course, Rust is faster and it has maybe more optimizations, but all the critical parts in Rust, we already have Java, we got some new developers. Let's not learn Rust right away. And Java is amazing. So there is something in Java, right? What we can do to make this even better. But the thing is, when you have many threads, that could be a problem. And her cat was also, when he was at home, always going into the ball of yarn and play with it, and it got stuck all the time. Sometimes their Java application was like that as well. So the problem with many threads is you can see it like a highway. You have a high-speed highway and traffic goes through there. It's just fine. But at one time, when you get more traffic to it, you get traffic jams. So a solution to that is add more threads, add more lanes. But you can't do that forever. And building more threads is expensive. In Java in memory, real-time, very money. So, and also you need to manage all of that. But we got our hero, JEP 491. And the cool thing about that is, it's all about synchronizing virtual threads without panning. And the best thing about this, it's lightweight. So it's very easy, and it's very scalable, and thereby efficient. But maybe you're thinking, I saw something like this before. That's true, but I will show you in. So, how do virtual threads work? So normally we have the OS kernel with a couple of threads, and we have the JVM on top of that with platform threads, but there's just one-to-one. So if one of them gets stuck, yeah, too bad for you. But with virtual threads, we see that on the right, it's like rotating seats on a very busy train. So we still have the OS kernel with the threads and a JVM with the platform threads, but we also have virtual threads. So if one virtual thread is stuck, we can just pin it and go to the next one and continue later on. So in that way, the thread is used more efficient. But this was already there in Java 21. So what's the difference now with Java 24? Now, like I showed you before, some of the new JEPs, the new features, are coming in waves. So they're coming in Java for the first preview, the second, maybe even the third and the fourth. It depends on how easy it's implemented. So in Java 21 was the first implementation. Now, with Java 24, they did some reruns, and now they optimized it very much. So now we have less overhead and better scheduling. That's the same, but better. And how does this work? For example, we have a synchronized block with a byte. We call it getData, and we have a byte array. And we want to read that. So we put it into a stream and read it. But there is an option this will block. And if that does, and on the old way, it would just block the whole thread. And now it will just go to the next one. And we can unmount it by, for example, in a synchronized block, add a wait. And then the virtual thread will unmount on that place, and it will just go on. And that was very important for Emma and her team. So we had no more meltdowns of Jan, luckily. And we had much more requests we could handle, because every time thread was blocked, now it could just go on and on and on. So now let's talk about the great JEP 485 adventure. Because of all these new JEPs, they invented JEP Friday. So once a sprint, they did something on the afternoon or the day, just depending on how full the sprint was. They took a JEP and got an explore with it and see what they can do with it and if it was relevant for them. So who here knows the Java stream pipeline? Couple of you. And who here was to the session of Venkat earlier this morning? Ooh, a lot of you. Oh, then we'll go fast through it. Now, we have also people in the audience who don't. So, normally when in Java 8, they introduced stream pipelines. So we can say stream off, some words, and we have a filter. There we say only use it if it's not empty, and a collect. And if we run this, we have 3 as a number of words. And just like Venkat also explained, we have the terminal prediction that's like the collect, and therefore we have the intermediate things. So the filter does not happen until the collect is there. So that was the old way. But now we have built-in operations. So wouldn't it even be better if we have a stream and we iterate over it, that we could do something like window fixed or something, let's just do something during the stream and not wait till the terminal condition. But that's not here yet. But with JEP 485, that was already there in Java 22, and then re-previewed in 23, and now it's finally here. And here you can also see all the JEP got different numbers in every version. So it's not like the first preview is the same, it always changes. And they already added some more built-in gatherers. Those 5 they added, there could be like a lot more. But if you also listen to Venkat's story, they can make so much of it, but you can also make your own. But do you want to? So if you make stream gatherers, really think on, why am I doing this? Do I need this? Probably not, but it's fun and you can do it. So what did they add? The map concurrent. That's like 1-on-1, but they have a limit. We have a scan, so then when it comes in the stream, we do it still 1 by 1, but it can go on and on. We have a window fixed where we say, okay, only this part, but that's again just for input we already have, or a window sliding, that's again with the stream, so we can say, I want 3 from this, 3 from that, just go on forever. And the fold, just like the name says it, you can money and fold them to 1. So if you want to flatten or something, you can use a fold. And maybe you're thinking, okay, but how does that look like? Don't read all this code just for the optimization. Just see how much code is in here. So this was without stream gatherers, and this is with. So it's a lot more readable, right? Empty. Who thinks it's more readable? Yeah, you're still like, select. So I think it's very cool that it went from this to that with the stream gatherers. So once again, we have always in the stream, we have the source, then we have some intermediates, and then we got the terminal, and then it will happen. And like I said, we can also create our custom stream gatherer. And here you see 2 uppercase, where we see are the inputs, and we got the element and the downstream. Oh, you don't see my mouse. Okay. The element and the downstream. And then we say, if the element ain't null, then we want to do it in uppercase. So the output would be, if we use ABC in small letters, a gatherer with our 2 uppercase gatherer, and make 2 lists. Ta-da! It's already there. And you can go crazy wild with all the gatherings you can create, but just try that one for a weekend or with some days with your company if you have time for that. But still, always, just like in your normal work, ask yourself the question, do I really need this? For the next slide, I would like to ask you if you can take out your phone and scan the QR code. Because Emma and Rice were very happy that they did complete their Jeb Friday, so they did a victory dance. Sorry, I couldn't notice. I had to rickroll you, sorry for that. So, is this all fiction? Yes and no. Of course, Emma and her team aren't real, but all the Java features I just shown you are real. And I think it's very cool. They have a lot of new Java features, what I already told you, that we don't need a lot of code changes for to make it happen. Since your phone's already out, I really like to improve myself. So if you can scan the left QR code, you can give feedback to my session. You can also give it later on and scan it just for now. In the middle is the QR code for all the mentioned materials. And on the right, again, my LinkedIn profile if you have any further questions. And for now, we also have time for questions. And you can find me on one of the social. So thank you very much. My name is Lutske De Leeuw, and thank you for listening.